Hello guys, welcome back to the channel. The paper we are solving today is IGCSE Physics October-November 2024 and this is the variant number 22. So the MCQ paper. Now let's start with the first question. Two forces with magnitude F1 and F2 act on an object at right angles to each other. So they're at right angles to each other. If this is F1, this must be F2. The angle is 90 degrees. They're asking you what is the magnitude of the resultant force. We all know that we can directly apply Pythagoras theorem here. And what it will say is, let's say you can draw it like this. F2 is here, F1 is here. Then your resultant force will be something like this. Right? So F1 squared plus F2 squared square root, whole root. So your answer should be A. Now, second question. A boy takes 30 minutes to cycle a distance of 8 km, then walks a further distance of 2 kilometers in 15 minutes. What is the average speed? Average speed is given by total distance by the total time taken. How much is the total distance? 8 plus 2. What is the total time? 30 minutes plus 15 minutes. But there is a catch here. In the units, according to answer, it is kilometer per hour. So you need to convert this 15 plus 30 minutes, which is 45 minutes, into hours first. You do 45 over 60, then you plug it in here in the formula, and you will get the answer as 13 kilometer per hour. So you sum up the distance 8 plus 2. Time is 30 plus 15, 45 minutes, but according to the answers, it's in hours. So you divide it by 60 to get the answer in hours. Then you divide it. Then you plug it in the formula 8 plus 2 over the number of hours that you get. All right. Now, a small light ball is dropped from top of a tall building. Which graph shows how speed of the ball changes with time? So this is indirectly they're asking you a graph of terminal velocity. When you drop something, initially it accelerates. Initial velocity is 0, but now it is under the effect of gravity. So it accelerates, but slowly this acceleration decreases. Why? We know that air resistance also increases. So as you're going down, air resistance is starting to increase upwards, right? And at terminal velocity, air resistance is equal to the weight. So the acceleration becomes 0. So your correct answer should be C. Initially, the speed is increasing, but as your speed increases, air resistance also increases, right? So air resistance is increasing, meaning the slope here is decreasing and ultimately it becomes 0. So this is your terminal velocity point. The correct answer should be C. Next question. Which statement about gravitational field strength is not correct? It changes the mass of an object. This is not correct. So this should be your answer. Let's check the other ones. It is equivalent to acceleration of the free fall. This is true. It is measured in newtons per kg. This is also true. Its magnitude is different on other planets. Yes, for Earth it is something, for Mars it is something, for Jupiter it is something. Right, so this statement is also true. The correct answer according to this question is A. Now, three liquids P, Q, and R have different densities and do not mix. All right. The liquids are placed in a measuring cylinder and allowed to settle. A small block is then dropped into the measuring cylinder, comes at rest as shown. So you drop the block from here, it slowly went down and it is at rest here. What it simply means is that the density of block is at least greater than density of R and density of Q. It's only then it is able to move on to a further below level than Q and R, right? So it is equal to the density of Q? No, it is larger. It is greater than the density of P? No. See, if it was greater than the density of P, then the block would have been here, but it's not. It's on top of P. So its density is less than P. It is greater than the density of R. Is this what we discussed? Yes, because R is at the top and the bottom block is at the bottom, nearly bottom, right? So it's at least greater than R. Your correct answer will be C. It is less than the density of Q. No, the density is greater than Q and R both. All right. Now, question number 6. The diagram shows a uniform beam pivoted at its center. All right. A student applies two forces F1, F2. Now, they're just trying to complicate this question to you by giving a lot of distances. What you should do is just remember what you have studied. You have simply studied moment of force is equals to force multiplied by the distance from the pivot. Right? Now, clockwise movement will be created by which force? See, clockwise is something like this, right? So, this F2 force is also trying to rotate something like this. So, F2 will create clockwise movement. And what is its distance from the perpendicular axis, pivot axis? D4. So, it should be F2 D4. So, our answer should be out of C and D. Now, let's have a look at the anti-clockwise movement. This force F1, it will try to rotate something like this, right? You get the idea? And which direction is this? This is anti-clockwise. What is its distance from the pivot? D3. So F1 D3. Correct answer should be D. Not a very difficult question. They gave you these extra distances just to confuse you. Question 7. Which expression can be used to determine the impulse on a tennis ball? We know that impulse formula is there. There are two formulas. One is mv minus mu and the other one is force times change of time. So if you have to figure out the impulse on a tennis ball, you have to pick one out of these two, mv minus mu or f into time. F into time is given, so your answer should be now. Which row shows the process by which energy in the sun is released? We know that sun undergoes nuclear fusion reactions. So it clearly means that our answer should be out of fusion is here, fusion is here, fusion here. So our answer should be out of B, C, or D. A is eliminated. Now, the process by which energy is transferred from sun to the earth, we know that it's a vacuum in between. So radiation is the only possible way. This eliminates option C as well. Now we have to pick between option B and option D, a method by which the energy is stored in earth. The energy is stored in earth in form of biofuels. So your correct answer becomes option D. Next question. An object has a mass of 20 kg. It is taken upstairs through a height of this much. What is the increase in gravitational potential energy? We know that the formula is mg times change of height. What is mass? 20. G for now I'm taking as 10 because the values are very different. So it will not make a difference. Delta H will be 4. So 200 times 4, 800. You need to pick an answer which is near to 800 and it's this only. So your answer should be D. You can take 9.8, that is what is required. But in this case, I am simply solved with 10. Now, question number 10. An electrician uses a lifting machine as shown. The lifting machine takes this much time to lift up a electrician at a vertical height of 3.2 meters. All right. The mass of the electrician is given, energy input is given in form of power. So we can say that input power is given to us. Input power is 2 kilowatts. All right. What is the efficiency of the lifting machine? So what is the formula for efficiency? First of all, efficiency's formula is equals to useful over the input into 100. Now it can be useful power, useful energy, or input power, input energy. It's the same thing. So input is given to us. We just need to figure out useful is how much. Now, useful in short, how much has been utilized, how much energy has been utilized. Now, what's happening here? This person of mass 72 kg is being lifted upwards at a height of 3.2 meters. Means there is a change in gravitational potential energy going on, right? And what will be the gravitational potential energy here? 72 times 9.8 times what is the height they're lifting him to? 3.2, right? When you multiply this, give me 1 minute. 72 times 9.8 times 3.2. This will give you 2257.92 joules. So this much energy is required to lift this person up in one go, right? So this is the input energy, not input, sorry, this is the useful energy which is required. All right. Now, what all of us can do is, we know that the input is this much, input power is given to us, and we can figure out the output power because we know the output energy, the useful energy required, and how much time is it taking. It is taking 4.5 seconds. So you divide 2257.92 by 4.5, and your answer will come out to be 501.76 watts. So this is the energy required, or you can say this is the useful energy, useful power, sorry, not energy. This is a useful power. Now you just plug it in the formula. 501 divided by, what is the input power? 2 kilowatts. So 2000 into 100. Now I think you already get the idea. The answer will be 25%, which is 0.25. In case you're a little confused about this question, how we solved it, I'll explain it to you again. Just give me 1 minute. I'll erase this. Now, in this question, simply input power was given to us and efficiency they were asking us. So we think about the formula. It is useful by input into 100. We know the input. We just need to figure out the useful power or the output power that is required to do the work. And then we can solve for efficiency, right? And how did I figure out useful energy? I figured out useful energy because this person is being transferred to a height. It means there is a change of gravitational potential energy. So we figured out gravitational potential energy and how much time it is going to take, 4.5. So this will give us the power because power is equals to energy over time, right? And the energy in this case is mgh, time is given 4.5. So from here I was able to figure out power is 500 watts, the output power required. And supply was how much? Supply was 2000. You have only utilized 500. So what is the efficiency? 25%. So 0.25. I hope you understood this now. Some altimeters use the change in pressure to measure height. If the pressure is 100 kilopascals at sea level on a particular day, what will be the pressure at the top of a 830-meter hill? All right. Now, in order to solve this, you need to figure out the formula, use the formula. Change in pressure is equals to density into gravitational field strength into change of height. All right. The change of height that is taking place here is 830. What is G? Let's take is 9.8. What is the density? 1.3. Now, for change in pressure, you know that as we go upwards, the atmospheric pressure decreases, right? So the larger pressure already should be this one. So I will do the change of pressure will be 100 kilopascals minus the pressure at the height that wherever you are going. So pressure at top. All right. Now, if you solve for this, 100,000 kilopascals minus 830 times 9.8 times 1.3, our answer is coming out to be 89425.8. So 89 kilopascals. To sum it up, your correct answer is C. In case you are confused, why did I do 100 kilopascals minus pressure at top? Think about this. As you go up the altitude, the pressure decreases. This is why the concentration of oxygen also decreases at the top, right? There is deficiency of oxygen at the top as well. Pressure decreases. Now, water can exist in three states: solid, ice, and gas. In which states is the motion of water particles only vibrational? It's only vibrational in solid state, which will be ice only in this case. Question number 13. A cube has sides 2 meter long. The cube contains a gas at pressure of 8000 newtons per meter square. The second cube has sides 4 meter long. So they've doubled the side. This cube contains same mass of same gas as the first tube at the same temperature. What is the pressure of the gas in the second cube? Now, what some students make a mistake in this is they will say that the temperature is constant here, so we can apply Boyle's law, and Boyle's law says that pressure is inversely proportional to volume. So if for 2 meters pressure here was 8,000, now we are increasing the volume, so pressure should half 4,000, and then they will end up picking the answer B, which is wrong. And in case you did this, feel free to let me know in the comment section. All right, this is wrong because pressure is inversely proportional to volume, not the dimension. Now check this out. What will be the volume here? 2 times 2 times 2, which is 8. And that is giving you 8,000. What is the volume here? 4 times 4 times 4, which is 64. And then you have to figure out the pressure here. Now just think about this. What is the proportion? 8, 64. It is 1 is to 8. Right? The volume is increasing by 8 times. Volume increasing by 8 times. So pressure should decrease by 8 times. Answer is A. Alright, I hope you understood this. The length, one of the side, they doubled. That is fine. But you need to look at the volume, not one side only. And volume is increasing by 8 times. So the pressure will decrease by 8 times. So answer is A. 8,000 over 8 is 1,000. Which row gives the correct name for each change of state shown? Gas to liquid is condensation, correct. Liquid to solid is solidification. So we already know the correct answer. Answer is B. And solid to liquid is melting, which is also true. In an experiment to measure specific heat capacity, they're simply asking you which expression gives the expression formula for specific heat capacity. We know that heat energy is equals to mass times specific heat capacity times delta T. So you can arrange for C, it will be Q upon M delta T, where Q is your energy change. So energy change over M delta T, your correct answer is C. Next question. Question number 16. Which statement about transfer of thermal energy is correct? All metals conduct thermal energy equally well. No, there are better conductors, there are weak conductors. So this is incorrect. Convection can only occur in solids or liquids. It is wrong. It can only occur in liquids or gases. Convection occurs in liquid because hot liquid is more dense. See, it does occur in liquid, but not because hot liquid is more dense. Hot liquid is less dense. So this is also wrong. The radiation that transfers thermal energy is a type of electromagnetic induction. Electromagnetic radiation, that is correct. It can be infrared, visible, ultraviolet. From the sun, the radiation or the heat we receive, it is in the form of ultraviolet, infrared, and visible. So it is correct. Answer is D. What is the number of wavefronts per second? We know that this is frequency, so the answer should be B. An earthquake under the ocean can produce a dangerous water wave called tsunami. It's a new information for all of us. Got it? The table gives typical data for a tsunami. Our student suggests 3 conclusions about the data. So let's look at the data first of all. If the depth is 7,000, the velocity is 948. If the depth is way lesser, the velocity is also less. And if the velocity is 948, the wavelength is 285. If it is 504, so the wavelength is also less in similar proportion. All right. The deeper the ocean, the faster the wave. Which ocean is more deep? 7,000. Is the velocity more? It is more. So is this statement correct? It appears so. This is correct. The longer the wavelength, the faster the wave. Let's see. If the wavelength is 285, the speed is more. If the wavelength is less, the speed is less. This is also correct. The faster the wave, the higher the frequency. Now, this is what doesn't happen. Frequency stays the same. See, V equals to F lambda is there. If V is being changed, lambda is being changed, frequency will be constant. So your answer should be 1 and 2 only. Option number B. Question 19. Which effect is this? This is diffraction. So we can say diffraction. Now, question number 20. What are the angles of incidence and refraction of the ray? Oh, this is a very simple question. Angle is given 50, angle is given 25. So I'll pick 50 and 25. That's it. This is my correct answer. It's not. We measure the angle of incidence with respect to normal. So 40 degrees is the angle of incidence, and this is correct, 25. So your correct answer should be 40 and 25. Do not fall for the trap they make for you. Always follow what you have been taught. Trust what you have been taught. So the angle you measure from the normal, 40 will be here, and refraction is already from the normal only, so 25. Correct answer is A, not C. Next question. An object is placed in front of a converging lens. The lens has a focal length f. The lens produces real and enlarged image. Now, this is the point to be noted. It's saying enlarged image. You should go through your notes if you do not remember this, but at 2f, when the object reaches 2f, then the image starts forming in the same distance away and the same size is there. All right. And as you move ahead of 2f, then the image size starts to increase. So you just need to pick an option where the distance is between 2f and f. Between 2f and f, because after f, virtual image starts to form, the one which is used in magnifying lens. So your correct answer will be B. What is the speed of electromagnetic waves in a vacuum? It is 3 times 10 to the power 8 meters per second. They have given it in kilometers per second. That is fine. So it will be 300,000 kilometers per second, because this is 300,000 times 10 to the power 3 meters per second. So now this becomes 8 zeros. All right. So correct answer is C. Next question. The starter in an athletics race fires from the starting pistol. There is a wall 60 meter from the starter. Take the speed of the sound 330. Also, it's just like this, that the sound will go 60 meters like this. It will get reflected and then it will be heard here. So how long it will take to hear the sound? You can apply the formula of echo directly. Speed is equals to 2 times the distance by time. What is 2 times the distance? 2 times 60, because sound will go like that, reflect and come back the same distance. So that is why 2 times 60. Time we are trying to figure out, speed you have to use as 330. So it will be 120 over 330 and answer should be 0.36 seconds. So correct answer is B. Next, the diagram shows magnetic field. Which one is the strongest? We know that the closer the magnetic field lines, the strongest they are. All right. So the correct answer A. This is the region where they're the closest. Answer is A. Next question. A positive ion in a vacuum moves at a steady speed. There is a potential difference between two parallel metal plates. All right. Okay. Which diagram shows the direction of electric field? Now, it's very simple. Electric field has the same direction as electric current. So if current flows from positive to negative, electric field also goes from positive to negative. And since positive is deviating away from the plate Q, it means plate Q must be positive and plate P must be negative. So it must be going like this. Q to P directly, perpendicularly, straight. So your correct answer will be option number C. Now, in case you're thinking, why is it not curved? It's not curved because the direction the field lines are straight. You might be getting confused because the positive ion is getting curved. So you might be thinking, oh, it might have something to do with the curve lines. It does not. What happens is it already has some momentum. The positive ion already has some momentum, some kinetic energy. So it's not possible to stop it immediately. It will slow down, but it traces a curve path then. All right. But it doesn't mean the electric field line's direction is diagonal. It stays the same, positive to negative, straight upward. In the circuit shown, voltmeter is given 2 volts, charge is 5 coulomb. You have to figure out the energy. We know that voltage is equals to work done by charge, and work done is similar to energy only. So work done is equals to V into Q. V is how much? 2, and this is 5. So your answer is 10 joules. The simplest question out of this paper is this one. 26, answer is C. Next, which diagram shows the current voltage graph for a filament lamp? Now, in filament lamp, we know that after some time, I'm sure all of you have noticed this, when you switch on the lamp, after some time, it starts to heat up. And when a metal filament starts to heat up, means temperature is increasing. So its resistance also increases. Now, just think about it. If the resistance is increasing, finally, then the current will start to decline, right? Now, so initially it will follow Ohm's law. V directly proportional to I, roughly it should follow. Why? Because temperature is not hot enough. It doesn't happen, right? When you switch on the filament lamp or the tube light, it immediately doesn't get hot. It takes some time. So initially it follows Ohm's law, direct relation, but after some time, when heat builds up, it goes away from the current starts to decrease. So that is why this. Alright, so the answer A should be correct. Now, if temperature was constant, then this graph would have been correct, but temperature is not constant in a filament lamp. The diagram shows an electrical circuit. Which statement is correct? You have to just do the relations. Now, just think about it. First of all, the current will start flowing like this, right? A1 is getting all amount of current because when this go down, here you have two paths. So the current will split up. Let's say it gets half here. It doesn't get half, it depends upon the resistance. It is 3 is to 2. So it will split in that ratio, but let's assume it will reduce in value compared to the current which was present in A1, right? I think all of us agree on this. Whatever the current at A1 was, at A2 it will be lesser and A3 it will be lesser because it is splitting. It's a parallel circuit, right? So we can say A1 has the highest, right? The A1 ammeter 1 has the highest current, so answer should be A. Now, moving on to the next question. The diagram shows an arrangement of resistors in series and parallel. Which equation is used to calculate the combined resistance? So for this, we know that these two are in parallel. So we will do 1 upon R2 plus 1 upon R3 is equals to 1 upon R parallel, right? Now it will be R2 R3 by R3 plus R2 1 upon R parallel. So R parallel is equals to R2 R3 by R3 plus R2. Those who already know the formula already, so you get the idea. I'm solving it from the start. So this is your R parallel. Now this becomes in series with R1. So you add it here, R1. So R1 plus R2 R3 by R2 plus R3. Your correct answer should be B. Next question. An electrical engineer has made a pair of components P and Q. The resistance of P decreases as the temperature rises. So this is a thermistor. The resistance of Q increases as the temperature rises. So this might be your filament lamp, let's say. The total resistance stays constant when the temperature changes, all right. And the two components are connected in series. So this is a point to be noted. In series, voltage splits across the components. All right, so let's see. If the temperature change causes the potential difference across the P to double, the potential difference across Q will always half. Now, by looking at it, it might seem obvious to you, yes, this should be correct, but it's not. See, let's say you have the circuit and you have a lamp here, another thermistor here. Assume this is a thermistor. This is not the shape for it, but you get the idea. And now let's say the potential difference was 10 here and 10 here. So the battery was providing 20 volts. Now what this statement is saying is that if the temperature change causes this voltage to become 20 volts, then this will always halve. This will always be 5. Now just think about it. Is the sum adding up to be 25? It's not, right? So it's not always the case. The statement is simply saying if one of them gets double, the other one should be half. And if we try to do that, the number itself is not adding up. This is 5, this is 20. So this is giving you 25. But what is the total voltage? 20. So this doesn't make sense. This is wrong. The difference between the potential difference across P and the potential difference across Q does not change with temperature. It does change. It changes and it splits in the ratio of resistance, but not like this, that if one doubles, one halves. It can be any ratio, any defined ratio. 3 is to 2, 3 is to 4, 4 is to 7. It can be anything, right? So this is wrong. The potential difference across component P increases as the temperature increases. The potential difference across component P increases as the temperature increases. When the temperature is increasing across P, its resistance is decreasing. And if the resistance is decreasing, voltage should also decrease because it's a series circuit. V is equals to IR, right? In a series circuit, I is constant. So V is directly proportional to R. Now, this is saying that when the temperature rises, and in P, when the temperature rises, the resistance decreases. If the resistance is decreasing, V should also decrease because V is directly proportional to R. Think about it. It's a good question. If you have any doubts, feel free to let me know in the comment section. So this is also wrong. Your correct answer should be D. Now, the diagram shows a wire XY moving upwards in a magnetic field. The current is induced in the wire. All right. The wire carrying current XY experiences a force because of its interaction with the magnetic field. Which row gives the direction of induced current and the direction of force experienced by the wire XY? Now, this question is asking you the direction of induced current. Now, according to Lenz's law, it says that the direction of induced current will be in the opposite direction to the force causing it. So the force should be opposite. Now, what you need to do is you need to make your left hand, flaming left hand you have to use here. The thumb should point downwards now. The thumb pointing downwards and the magnetic field pointing towards the right because it is north to south, right? So thumb downwards, magnetic field towards the right. Your middle finger will be pointing into the screen or onto the plane of paper. So the direction of current will be x to y, and the direction of force will be downwards. They're asking about the induced current direction and that will be in the opposite direction. Alright, so the correct answer should be A. It's a good question. Next question. The diagram shows a magnet being pushed into the coil, alright, by sensitive 0 voltmeter. Alright. So this is again a Lenz's law question. What you need to simply remember is the induced EMF is induced in the opposite direction. Now, what does opposite direction means? Just think about it. If the magnet is trying to enter, Lenz's law will say, do not allow this magnet to enter. So it will try to repel it. It will try to repel it. But once it is inside, according to Lenz's law, what happens is, now the coil will try to attract the magnet from going away. So it's simply like this. You're not allowed inside. You're not welcome inside. But once you're in, you're not allowed to go. So it keeps on alternating. So now just think about it. When this is entering inside, it's deflecting like this. When it will try to go out, it will be the opposite, right? Just use this analogy. You're welcome inside. You're not allowed to enter, but once you're enter, you're not allowed to leave. So it's the opposite, right? So when it is entering, it is towards the left. When it will try to leave, it will be towards the right. So towards the right is only this one. And when it's in the middle, it will point in the middle. So correct answer should be C. Just think about it. Go through the Lenz's law theory from your coursebook. You will understand this properly. What is the purpose of the brushes and the splitting commutator? We know that it is used to ensure the continuous supply of current. After every half rotation, the direction of current changes. Why? To make sure that the coil keeps rotating in one direction. So the correct answer should be B. Next question. The diagram shows beta particles being directed towards the poles of magnet. In which direction will the beta particles be deflected? Now, it's a very simple question. I'll explain what you need to do here. You will have to use your Fleming's left hand rule and your middle finger is the direction of current, right? Middle finger is the direction of current. Now, beta particle is going towards the right. Beta particle is an electron. If electron is going towards the right, the current should be towards the left, right? So your middle finger using the Fleming's left hand rule should point towards the left, and your magnetic field should point towards north to south, so downwards. Middle finger, left, magnetic field, downwards. What is the direction of thumb? I'm sure it is coming out to be out of the page. It's a little difficult to make, but give it a try. I'm giving you the tips. Your magnetic field should be upward. So your index finger should be upwards and your middle finger should be towards the left. And if you do this properly, your thumb will point out of the plane of paper or out of the screen. So your answer should be B. An alpha particle and beta particle have the same kinetic energy. Why does alpha particle has more ionizing effect? First of all, alpha particle have larger charge. So alpha has a larger charge, alpha has a larger charge, alpha has a smaller charge, out, alpha has a smaller charge, out. We need to decide between A and B. So this is same here, and a larger velocity and a smaller velocity. Now just think about it. Alpha is heavier than beta particle. Beta particle is simply an electron. So something is heavy, it will probably have less velocity, right? So with a smaller velocity, answer should be B. Smaller velocity so that it is closer to an air particle for a longer time. This is also the reason why I directly told you how to answer, but this is also the correct reasoning that the more it is in contact with the air particle for more time due to its less velocity, then it will be more ionizing. Correct answer is B. Now, next question. A student is carrying out an experiment to measure the radiation from radioactive source. He uses radiation detector and records the total counts in 5-minute interval. All right. He does this 3 times with the source present and 3 times with the source absent. Now, with the source absent means this is the background count, but the background count is also varying. That is fine, understandable. So let's do one thing. Let's take the average of this. 25 plus 28 plus 22 over 3. So background count rate is coming out to be 25. So it is coming out to be 25. Fine. Now, in total 5 minutes, the count is 68 here, 73 here, 69 here. So if we do 68 minus 25, 73 minus 25, 69 minus 25, this will turn out to be 43. This will turn out to be how much? 73 minus 25, and that is going to be 48, and 69 minus 25, that is going to be 44, right? Now just try to understand what I have done here. I calculated the average background radiation, and now total counts in the 5 minutes with a source present. So this is counting the source as well as the background radiation. So I will have to subtract the background radiation in this to get the actual value of the source. This is the radiation entirely from the source that we have calculated, right? But this is for how much time? 5 minutes. So 43 over 5, 43 divided by 5, it is 8.6. 48 divided by 5, it is 9.6. And 44 divided by 5, it is 8.8. So your answer should fall in this range, and they're also asking the average corrected count rate. So you get the idea. It should be nearly 9 counts per minute. So the correct answer is B. It's a very good question. I will explain this to you again. Background count rate was given, but it was variable. So what we did is we took the average. The average is coming out to be 25. All right. Now the count rate is given including the source. So this count rate is for source as well as background radiation. But if you want to figure out for source, you will have to subtract the background radiation, right? So we subtracted the background radiation 25, 25, 25. We got this as the value of source only. but this is for 5 minutes. And you have to figure out and only for the source, not background. So this is why we had to subtract for background. Now this is for 5 minutes, but we need to figure out per minute. So per minute, we divided all three values 43 by 5, 48 by 5, 44.5. We are getting somewhere between 8.6 to 9.6. So the correct answer should be B. A very good question. Now, this is also a good question. Most of students in this question will end up picking the answer B instead of C. And I'll tell you why. See, the count rate measured near a radioactive source drops from 542 to 94 in 12 hours. The background count rate is constant at 30 counts per minute. Now, just think about it. This is 542, this is 94, but this is including the background count rate. So 542 minus 30 and 94 minus 30, this is 512, this is 64. So in 12 hours, this much got, we can say this much got reduced. Now, if you start doing the half-life, we do not know the value, that is what we are trying to figure out. But 512 half is 256. Half of 256 is 128. And half of 128 is 64. Means you will have to half it 3 times to get 64. Right? I hope this makes sense to all of you. In order to go from 512 to 64, you will have to half it by 3 times. And you're halving it by 3 times under what time? You're taking 12 hours to half it by 3 times. Now, 12 hours to make it half by 3 times. So just half it 3 times. So what should be the half-life? 4 hours should be the half-life, right? Because I think you got it now, right? For 12 hours, what we are doing is we are halving it by 3 times. Half, half, half. So 3 half-lives. 3 half-lives we have done, but how much time it took? For 12 hours. So what is the time for one half-life? 4 hours. So the correct answer is C. Now, what happens when a protostar becomes a stable star? The inward forces are balanced by the outward forces. So the answer should be B. Now, question number 39. There is a table. They have given lots of data for the 4 planets. Let's look at the statements. As the mass compared with the Earth increases, so mass is increasing, let's say Earth, and then Jupiter, it is increasing. The average density increases. Is the average density increasing? It's not. So this is wrong. As the mass compared with the Earth increases, the gravitational field strength increases. As the mass compared with the Earth increases, the gravitational field strength increases. Let's see. So from Earth to Jupiter, the gravitational field strength is increasing, right? From Earth to Uranus, the gravitational field strength is again increasing. So yes, this statement is right. As the average density increases, the gravitational field strength decreases. Now, I'll directly point to you that this is not correct. Why? If you look from Mercury to Earth, Mercury is 5.4, Earth is 5.5. So the average density is increasing. According to this statement, the gravitational field strength should decrease now, but it's not. It's increasing 3.8 to 9.8. So this statement is also wrong. The average density is directly proportional to gravitational field strength. It's not. Sometimes it increases, sometimes it decreases. You can check the data. So this is also wrong. Correct answer is B. Now, the last question. Which quantity is an estimate for the age of universe? We know that the inverse of Hubble's constant gives you the age of universe. So the answer should be C. Alright, because the unit of Hubble's constant is second inverse. So you reciprocate this and this will give you the time. So the correct answer is C.